Hey. Video A11 algebra tours, nth roots. So now instead of taking just square roots, we're going to take third roots and fourth roots and fifth roots and things, and they're not too bad. They're a little bit tricky to wrap our minds around maybe the first time we see them, but maybe the cube root of 8. You know, what is the cube root of 8? What do you have to multiply by itself 3 times to get to 8? Correct. 2, right? The cube root of 8 is 2. I'm going to write this like this for a second. So it looks like we're doing what we were doing before, right? If I take 2 and cube it, and then take the cube root, I get back right where I came from. So we might say, as we said before, that f of x equal to x squared and g of x equal to square root of x are inverses for all non-negative x, right? And same thing here, x raised to the n and the nth root are inverses, provided your domains are restricted accordingly. So let's see here. I would like to look at something. The cube root of minus 27, right? The cube root of minus 27. What do you have to raise to? So raise to the third power to get to 27. I hear you. You're thinking it real loud in your head. Minus 3 cubed, right? And so minus 3 is the cube root of minus 27. Nth roots, remember when we tried to take a square root of a negative number, we had to use imaginary numbers, and that same kind of thing happens here. We cannot take we cannot take an even root of a negative number without using imaginary numbers, right? The fourth root, or an even root of a negative number, is a complex number, imaginary number, and so be careful with that, right? Don't be too tricked by the nth roots. They'll throw some negatives into odd nth roots, and you can do those. Those are fine. So a simple problem to begin with, the fourth root of a to the fifth times a to the sixth. So the way we do these is we say, okay, a to the fifth is just a to the 4 times a, and b to the 6 is really just b to the 4th times b, and I can rearrange things. These are multiplication, commutative power, and remember that a square root of a product is a product of square roots, so I'm going to write the fourth root of a to the 4th times b to the 4th times the fourth root of a times b. So I just kind of rearrange things. This one I could rewrite too as a to the 4th, b to the 4th. Notice is the same as ab raised to the 4th. Right? Either way, I get ab times the fourth root of ab. And that one's not so bad. I will move the camera a little bit. A fifth root. Oh gosh, a fifth root. Don't worry about them so bad. I know you don't have these in your head. And so you enter 2 to the 5th in your calculator, 3 to the 5th, 4 to the 5th, 5 to the 5th, until you find one that divides it. And guess what? They're all cooked up problems for you, so you will not have to look very far. As a matter of fact, you will find fairly quickly that 2 to the 243 is the same as 3 to the 5th. That makes things nice, doesn't it? Can you express this as a fifth power? Remember that when you raise powers, you multiply the exponent. So could we write it like this? We sure could, and we'd have to put a 4 in there, huh? Do the same thing here. B to the 5th raised to the 5th power is b to the 25th. So, once again, 5th root of 3 raised to the 5, 3. 5th root of a to the 4 raised to the 5, a to the 4. 5th root of b to the 5 raised to the 5, b to the 5. Okay? So, going over to this one, we have cube roots. So, I grab my calculator and I do 2 cubed, 3 cubed, 4 cubed, and I find, oh, guess what? 4 cubed is 64. So, I can write this as the cube root of 64 times 2 x cubed times x squared and y cubed times y to the fourth. Now we'll rewrite things a little bit here. This is the cube root of 4 cubed times y cubed. Oops, I'm going to do the x there. I like to write my variables in alphabetical order. X cubed times y cubed. And what do we have left over that we haven't used yet? We have a 2, an x squared, and a y. Ah, we can take more out, can't we? Look at this. We can write this as y to the 7th. We can write as y to the 6th times y. But y to the 6th can be written as y squared cubed. Y squared cubed is y to the 6th times y is y to the 7th. So, let me rewrite that again as y squared cubed. And now I'll go back. We didn't use the 2. We have a 2 there. We have an x squared there. And we have a y. Right? All these things are perfect cubes. I can pull them out. 4 is the cube root of 4 cubed. X is the cube root of x cubed. Y squared, cube root of y squared cubed. And I have left over here 2x squared y. You are done when there are no perfect nths that divide the numbers left, and your exponents on your variables are smaller than your root you're taking, right? Okay. I can't right now with the tools available to us take a cube root of a square or a cube root of a y. So there we're stuck. I'm going to send you a worksheet that you can work on, and you can do it over the weekend and work on it. I will put it out Thursday. Yes, Thursday. It's Thursday now. You're watching this. It's Thursday. Yes, I'm talking in my head. So do the ones that are not square roots, right? The previous assignment you did all square roots. So on this one, do the one that are not square roots, and I will send you the answers. Let me know if you have any questions on them, huh?